So as we begin this video on the exponent rules, I would like you to make sure that you have your packet out and that you're taking notes in your packet. If you see on the very first page there, you'll see that there are two boxes like what you see right now. So we're just going to go over those problems first. So if you look at the first one, and you should remember this is review, when you have the same base, then what you do is you keep the base and we just add the exponents. So 4 plus 3 is 7, and that would be the answer. Similarly, with division, we're going to keep the base, but instead of adding the exponents, we're going to subtract the exponents. So 10 minus 2 is 8, and that would be the answer for that one. And again, these are reviews. So multiplication, we keep the base and we add the exponents. Division, we keep the base and we subtract them. All right, a little bit different when we have a power to a power. So what we do is we keep the base, and this time we take these powers, the 2 and the 6, and we multiply those. Okay? A little bit different than when we are looking, for example, the one that says multiplication. With the one that says multiplication, if you look here, we have 2 bases and we have 2 exponents. So that's where we keep the base and then we add the exponents. However, if you look down at the one that has to do with powers, you'll see that we only have 1 base here and we have 2 exponents. So when that happens, we keep that base and we multiply those exponents. All right, let's look down at the power of a product. So what we're going to do here is you can see that we have a power right here on the outside. So I'm going to take that power and distribute it through to everything on the inside of the parentheses here. All right, so let's look. So first of all, I'm going to start by taking that power and distributing it through to the 5. So what I mean by that is I'm going to make that 5 squared, and I'll simplify that in a minute. Then I'm going to take that power and distribute it through to the x. Well, that x is to the first power, so really what I'm doing is x to the first, and then taking that and raising it to the second. Okay, and that's our power rule from the box up above. And then lastly, I'm going to try to make my arrow look like this. Here we go. I'm going to keep that y. Okay, and that's to the third. And that too is also going to get distributed through it, again as a power. So let's just kind of simplify this. And you don't necessarily need to do this all written out, but I'm just trying to give you a written explanation, and in the future you can probably do some of this in your head. So I'm going to do 5 squared, which is going to give me 25. And then remember again that if you have a power to a power, we multiply those exponents. So that's going to be x to the second. And then one more time, we have a power to a power. So we're going to multiply those exponents. So that would be 25, x to the second, y to the sixth. All right, so let's look at the power of a quotient. Kind of similar to the one that we just did with the power of a product, in the sense that when we look at this 2 here is applying to both the numerator 3 as well as the denominator 4. So I'm just going to kind of distribute that. So that's going to be 3 to the second over 4 to the second, which would give me 9 over 16. Okay, so work down your page and look at question number 2. And again, remember that you're taking notes in your packet. So what I'm going to do is I am going to take that exponent of 3 in the numerator, and I'm going to distribute that as an exponent, mind you, through to everything inside the parentheses. When I do that, I'm going to get 4 to the third. Remember, we have a power to a power, so that's going to be x to the sixth, and another power to a power, so that's going to be y to the ninth. Right? And I'll fix that and simplify it in a minute. Now in the denominator, there's really nothing to do at this point, so I'm just going to write that as 24 y. All right, so 4 to the third is 64, Then I have x to the 6th, y to the 9th, and that whole thing is over 24y. So let's see what else we can simplify here. I see that 64 and 24 both have a factor of 8. So I'm going to divide by 8, and that will give me an 8 up here. And if I divide by 8 in the denominator, I'll have a 3. Now I also notice right here that I have a y to the 9th, and in the denominator I have y to the 1st. So remember, when you have division, that you can subtract your exponents. So let's just go one extra step here. Let's put that 8, and let's put that 3. Now x to the 6th, there's no other x's there, so we're just going to bring that down. And then we will be left with y to the 8th in the numerator. Okay, because if you look at this, we have a y to the 1st here, and we have a y to the 9th here. So if I cancel a y from both the numerator and the denominator, I'm left with 8 more y's left in that numerator. Okay? So then this would be our answer for number 2. All right, so now if you turn the page, and let's look at number 4, 0 exponents. If you look in the box, it says x to the 0 equals 1. Basically what that means is any number or any variable raised to the 0 power will always be 1. You can take your calculator and plug in any number that you want, and when you raise it to the 0 power, you will get 1. So then, in this case, if we're looking at number 4, you could put this in your calculator to verify it, but any number to the 0 power is going to be 1. Right, now if we look at number 5, and remember, again, you're taking notes in your packet, you have to be a little bit careful here because only the m is being raised to the 0 power. The 3 is not, so we leave the 3. It's almost as if we were writing it like this, okay? These two statements here are equivalent to one another. You don't need the parentheses, though. So in this case, if we keep going, we keep the 3, and we know anything, whether it's a number or in this case, we have a variable, that variable being m. Anything to the 0 power is going to be 1. So then our final answer here will be 3. All right, now if you look below the 0 exponents, you'll see it says negative exponents. And in the box on the left, it says x to the negative b equals 1 over x to the positive b. So basically, the little cheater shortcut is if you have a negative exponent and you want to make it positive, you can move it to its opposite position. In other words, if it's in the numerator, if we move it to the denominator, it makes it positive, like in that first box. And then if you look at the second box, it says 1 over x to the negative b. Okay, now look at that. We do have a negative exponent, but it's in the denominator, so we move it to its opposite position. In other words, in its numerator, and that will make the exponent positive. So let's look at number 10. So 10 says m to the negative 4th. Well, that's a negative exponent, and currently, if you want to think about this, this is really over 1. Okay, so that m to the negative 4th is in the numerator. So the way that I can make that positive is to flip it, and that would become m to the positive 4th, and we would put a 1 to hold place up top. Okay, so if I'm just trying to rewrite these using positive exponents, then this is what my answer would be. Again, I'm trying to rewrite it using positive exponents. So if we look at number 11, we can clearly see that your m to the negative 4th is in the denominator. So the way that we make that positive is by moving it to its opposite position. So if it's in the denominator, we're going to move it up to the numerator, and that will make the exponent positive. Now technically, we can keep this over 1 if we want to, but that's just kind of ugly looking, so we just write it as m to the 4th. Okay? So negative exponents. If they're in the numerator and you want to make them positive, flip them down to the denominator. If they're in the denominator and you want to make them positive, flip them up to the numerator. Now 15 is kind of a fun one because we have a fraction and it's raised to a negative exponent. All right, so this really isn't, don't freak out, it's really not that difficult. All we do, now remember, if we want to get rid of a negative exponent, we move something to its opposite position. So if it was in the numerator, we move it to the denominator, and vice versa if it's in the denominator. Well, here we already have a fraction, so the cheater way of doing this is just take that fraction, look at this, just flip the fraction, and guess what? there's your positive exponent. Okay, so all I did was flip the fraction in the parentheses, and then the exponent becomes positive. Now, if you want to go a step further, that 4 really is the power of both the y and it's the power of the x. Okay, and now you can see you have a fraction, and all your exponents are positive. All right, so let's look at number 18. Now, this one's kind of got a lot going on with it. So let's just look at the denominator. I think that's the first mess we want to deal with. We have a negative exponent, but that negative exponent is being applied to every single thing in here in the parentheses. So rather than taking this whole set of parentheses and flipping it up to the numerator, what I'm going to do is I'm going to just distribute this negative exponent first. I think that maybe that might be a better way to go. Okay, so when I say that I'm going to distribute it through, this is going to get a little ugly looking here. I'm going to apply it to the negative 2. I'm going to apply it to the x to the negative first. I'm going to apply it to y to the third. And then lastly, I'm going to apply it to that z right there. Let me see if I can get an arrow out of that. There we go. Okay, so for right now, I'm just going to leave the numerator alone. Okay, that seems to be the least offensive thing in this whole problem right now. So let's rewrite the numerator, and here we go with the denominator. So what that's going to do is that's going to give me negative 2 to the negative third power. Okay, I'll deal with that in a minute. Now, remember, I have x to the negative first raised to the negative third. That's a power to a power. So we keep the base. And remember, we multiply the exponent. So negative 1 times negative 3 is a positive 3. That's nice. All right, so let's go to the y's now. So I have y to the third, and then raised to the negative third. So power to a power again, so we multiply, and we get negative 9. Not so nice, but we'll deal with that in a minute. All right, last one, let's look at z. Well, z right now is z to the first, and then raised to the negative third. So power to a power again. We multiply, and we get negative 3. Okay, still ugly, but better. We're getting there. All right, so let's move on down here to the bottom left. So what I'm going to try to do now is I'm just going to take, I think, you don't have to do this in as many steps as I'm going to, but I'm going to take this and deal with this first. I'd like to get rid of the numbers first. So what I'm going to do is I'm going to keep that 8 in the numerator, and now I'm going to take that negative 2 and I'm going to raise it to the numerator, and if I do that, that makes that negative 3 a positive 3 power. Okay? And then I'm just going to rewrite everything down for right now. You don't have to do this in multiple steps like I'm doing, but I think in the beginning it makes it a little less confusing. So look at what I'm doing. All I'm doing is copying everything else down for right now, and I'll deal, I'll deal with all the negative exponents in the next step. Okay, so then I've got z to the negative third. There we go. All right, so if you look at this right here, I've got negative 2 to the third power. So that would be negative 2 times negative 2 times negative 2, which is going to give me negative 8. So that negative 8 times the 8 in the front is going to give me negative 64. Okay? All right, now I'm going to start moving exponents. So I look here, and I see that I have a negative exponent. So I'm going to bring that down to the denominator. So what I'm going to do is just, I already have, if you look, I already have x to the positive third. So I'm going to leave that x to the positive third. And now I'm dropping down an x to the second. Okay, I'll simplify it in a minute, but let's just leave it. Look in the numerator. If we go back to the numerator here, I have y to the fifth. Well, that's positive, so I'm just going to leave that. So I'm going to leave that as y to the fifth. I also have z, and that's also positive, so I'm going to leave that alone. Okay? All right, let's go to the denominator. So here's the x to the third. I have it right here. I have y to the negative ninth, and I can't have that, right? So I'm going to move that up to the top. So I'm going to make that y to the positive ninth. All right, let's keep going. So I still have this in the denominator. This one up to the numerator, and let's look at this one. Z to the negative third, can't have that. So I'm going to move that up to the numerator as well. So that's going to become z to the positive third. Oops, let's make that look like a 3. There we go. Okay, so let's just kind of look at what we've got here. And if we look at everything, that's a negative number, not a negative exponent, so that's fine. And all these exponents are positive, and all these exponents are positive, so we're good. Now what I'm going to try to do is I'm just going to try to combine like terms. Like here I can combine because they have the same bases, and I see that I have 2 y's, and I see that I have 2 z's. So that's what I'm going to do in my last step. All right, so let's come back down here. Let's make a fraction. So negative 64. Okay, let's just deal with the numerator first. So I have y to the 5th, and I have y to the 9th. Okay, so if we look at that, you'll see that that's going to give us y to the 14th. So let's write that y to the 14th. Okay, now let's look at the z's. We have z to the 1st, and we have z to the 3rd. So when we add those, we're going to end up with z to the 4th in the numerator. All right, lastly, let's look at the denominator. We have x to the 3rd and x to the 2nd. So we see that we can add those, and we will get x to the 5th. So dun da da dum. Everything there now has positive exponents. We have one variable represented in each numerator or denominator, and we're all done.